Dave, what is this little gadget that I've seen you carrying around all week?
This is the LAVA LMP, which stands for the Lava Multi-Purpose Probe. And basically it's addressing a problem in automated testing that's existed for a long time, which is that if you want to do hot plug testing of devices, typically you have to have somebody standing there plugging and unplugging the whatever particular thing you were testing, such as Ethernet or SATA disk drive or HDMI video. So what this is a stack of boards that answer that question and give us an automated way of doing hot plug testing. So up here at the top, we've got a little board that's got Ethernet, and underneath you can just see possibly the SATA connectors. This next one down is level shifted GPIO and audio. You can see the audio connectors there and on the side. And I'll explain level shifted GPIO in a little while, but next down we've got HDMI. And with HDMI we can do pass-through, disconnect, which is the usual hot plug sort of testing, but we can also fake the EDID, which is the identification of the type of monitor that's connected to. So you can actually test how your kernel is reacting to changes in resolution, maybe very rapid changes in resolution requests or pixel depth or that sort of that kind of configuration. The next board down is USB on the go. So a lot of Android devices support USB on the go. Basically it means that through a USB cable you can add functionality. You can add a flash drive, for example, to a board. And in this case what we have is these here are these are the serial control lines. This is how we control the LMP board. It's just a serial interface. We send information down that tells the board what to do. This here connects back to the host, and this here connects to the device under test. Then you put whatever on-the-go device you want in this portion here, and we can switch between host and device under test. The next one down is the thing that we've been trying to get working for the last year and a half in one form or another. Not in this particular form, but we've been trying to get something that will do this for us. And that is the SD MUX. I'll try and take you through this. It has a similar form to the USB on the go, but you've got a couple of little SD card slots on there. We've only got one SD card in the moment. We're in the middle of doing some testing with this. And that has the same serial interface and another USB interface which goes back to the host. And this allows us, with this little adapter here on the end, to plug into a device and make it see that SD card or switch it over so that the host can see the SD card. This way we can write a bootable image onto the SD card, switch it over to the device under test, power that on, and we can at last, for those devices like the Pandas and the Arndales and the like, we can now test the bootloader, because previous to this, with the master image technique we've been using, the one thing we couldn't do was test the bootloader. So we could test an image, test the kernel, but if the bootloader was broken, we would never know. And so you could actually say, yes, that all looks good. You then could try and boot a master image of that, and it would fail. So now we're in the golden era of being able to test bootloaders. So that's the brief outline of what all the functionality is. So
realizing that we don't have a board to hook up to and that sort of stuff right now,
yeah.
Can you run through at least part of the demo, what you can see on the screen
Sure.
when you hook it up, that sort of stuff?
We're in the process at the moment of integrating this into Lava. I've got the SD MUX partially integrated. The rest of the functionality is getting there, but at the moment we can control the board remotely and see what happens. So if you look on here, I've got a little web browser, and we can look through it using, there's a little daemon running on the board, on the laptop, which will talk to the firmware of the LMP board, a particular LMP board we're connected to. So for example, if I plug in the Ethernet board, you'll see first of all a little light, which is all very exciting. And immediately the daemon recognises that it's been plugged in, and I've got the controls available for it. Now this is actually a really nice piece of the way the firmware was designed. I haven't mentioned that this was all designed by Andy Green, including the firmware, and it's very elegant, very simple. But when you probe the firmware, you say, what are you? It comes back and doesn't just say, oh, I'm an Ethernet board. It tells you how you can control the board. It tells you all the controls. And that's all from a little processor on the board there. So the things I can do on this one are I can disconnect or I can pass through. Obviously the two possible options. You probably won't be able to hear this, but I'll give it a shot. But there's a little click from the relay when you switch. Don't know if you got that, but there it was there. So this is a manual control. Obviously, the Lava control will be all automated, and there will be commands within Lava to say, switch this device this way, switch it that way. If we go down a couple more to the HDMI, there's also the option there for the fake EDID, and there's a command you can send to the board to give it the EDID that it needs to reply with, the fake configuration. But that again has pass-through and disconnect. Just a little anecdote, when we first were getting these manufactured, went down to the contract manufacturer, we sat there, they all programmed up first time, which was very nice, we were very pleased with that. We connected a DVI monitor and out to a laptop, and we switched it, and it switched on and it switched off, and it was, I know it sounds kind of geeky, but we were kind of excited. It was just an awesome time. So if I go down, apologies, I should explain these little strings underneath. These are some debug for us. These are the strings that are being sent by the little JavaScript application on the website to the LMP to control it. Yeah. So down on the SD MUX, this is probably the most complicated of the interfaces, because you've got switches to control whether you look at the SD card in the A slot or the B slot, and the device, whether you switch it to the host or the device under test. So you've got disconnect, USD-A, you can switch from A to B and back. Obviously what we do in Lava is we initially switch it to host mode. It mounts just like a USB flash drive. We then write the image out, switch host mode off, switch it on, all automated of course, and boot the image. And that's pretty much it.
I guess that was going to be my question, because it with this demonstration it seems like it's still a manual process, but I think there's a script that people can run, and then you can tell it how many times you want it to run that, and test it for each of the different boards.
So we provide the commands within Lava for you to switch, to pass through, to disconnect, or whatever. And you can then you have complete control of how many times you run that, at what speed you run that. So you can see how it reacts to having it Ethernet switched 1,000 times, switched on and off 1,000 times, that sort of thing. The work for the SD MUX is all, the code is integrated. We're just going through some debugging at the moment. This is still very much a work in progress. And we were, in fact, Tyler and I were working at it quite late last night. But we've got the dispatcher working with it and writing out blocks of data onto the board, and all that sort of stuff. So it's really exciting.
Well, I'm excited to see this demoed. I'm excited to see where we're at when we're at TechCon in a few months, and where we're going with this. So thanks so much for taking time to demo this today.
You are more than welcome. It's really good to show it off. It's one of my pet projects.